Ladies and gentlemen, boys and girls, children of all ages, welcome to Mr. McMurdo's class, Mr. McMurdo's homeroom. This is take 2, because we have a little bit of trouble acting like we have some sense. I know some of you don't have sense, but please pretend. That's all I ask. Please pretend. All right, so today we're going to do a quick lesson on adding and subtracting fractions using models. Using models. We tried an example of that yesterday. Some of you worked in the book to see if you could figure out how to do it. Some of you got it pretty quickly. Some of you had difficulties doing it. So I figure I'll go over, I don't know, pick a number between 1,000 and 1,002, Tristan.
1,001.
Good. 1,001 problems. As an example, we'll have an assignment on this for 10 problems. So hopefully after I go over some of these, you'll be able to do it. Some of you were doing it yesterday without using the fraction pieces, and the whole point of yesterday's lesson was to use the fraction pieces. So today when we do it, I want you to use the fraction pieces. Hannah wants to know if you can work with a partner since I don't have enough fraction pieces for everybody. And Hannah, that is okay. I'm good with that. At the end of today's lesson, I need you to know how to add fractions with unlike denominators using fraction pieces. Because in the next day or two, we're going to subtract fractions with unlike denominators using fraction pieces. Then we'll eventually get into without the fraction pieces. And then we'll throw in some mixed numbers and improper fractions. And we're just going to make this fun. I'm just saying. We're going to make it fun. Because anytime we can do some hands-on stuff, it makes it fun. All right, so let's try this again. Our first problem, as is up here, we have 2/5 plus 3/10. 2/5 plus 3/10. Well, we're going to start with our whole number. Our whole number is 1. We have one whole. This gives us something to compare it to. It's going to tell us if I have my answers greater than 1 or less than 1 or exactly 1. That's what I'm talking about. So our first problem is 2/5 plus 3/10. So I start by taking 2/5. And then I go, that's my first addend, 2/5. My second addend is 3/10. So, Caitlin, this is less than 1. This is less than 1. So it is a proper fraction. Yes, exactly correct. It is a proper fraction. Caitlin, if it was greater than 1, it would be called an improper fraction. Awesome, an improper fraction. So now we have to find pieces with the same denominator. Okay, some of us had a problem yesterday that realizing you have to use the same denominator in the pieces below. So first of all, I'm going to show some guessing and checking, and then I'm going to show you how you could use some knowledge that you've already learned in previous lessons, and then you also made a foldable that had the directions on how to find least common multiple and greatest common factor. So we'll move from there. So I need to find pieces that fit exactly under there. Let's get, I'm going to try 8ths first. I'm going to try 8ths. Okay, so does 1, 2, 3, 4, 5, 6 8ths fit exactly under there? No. 6 8ths is greater. Now 5 8ths, does 5 8ths fit exactly under there? No, 5 8ths are too small. So I know right now I can't use 8ths. What about 4ths? Yeah. I can try some 4ths. Is 2/4 going to work?
Yeah.
No. 2/4 is too small. Is 3/4 going to work? No. 3/4 sticks out past my two addends here.
What about 6?
You want to try 6?
Yeah.
let's try some sixths here. 4/6 is too small, and 5/6 is too big. So you want to try some? Let's try some. Did we do 12ths yet?
No.
Let's try some 12ths. Okay, that ain't gonna work. We can try some 16ths.
Yeah.
16th's gonna work?
No.
No, it's too small. Oh, Gage wants to try 10ths. Let's see if we can match up the 10ths exactly. Hey, look. If I have 4/10ths, that's going to be the exact same as saying 2/5. So I wanted to change this so that they have a common denominator and put them over 10, because once I have a common denominator, y'all know how to do this.
Yeah.
I've just figured out that 2/5 is equal to the same value as 4/10. Man, that's awesome. I didn't even really have to do any math to figure that out. And so, how many tenths more do I need? 3. And I don't even have to put these 3 up here, because obviously 3/10 is going to match 3/10. So 3/10 matches 3/10, which gives me an answer of 1, 2, 3, 4, 5, 6, 7/10. Now, when I'm dealing with fractions, I always need to see if they're in simplest form or lowest terms. Simplest form or lowest terms. And what I do for that is I use the greatest common factor, which once again, you have notes in your journal on how to do. The greatest common factor. So I need to find all the factors of 7 and all the factors of 10 and find the greatest common factor there is. Every set of numbers has a greatest common factor. Every set. Just like every set of numbers has a least common multiple. So I'm going to figure out, before Gregory passes out from wanting to answer here. Gregory, what are my factors for 7?
It's prime, so 7 and 1.
Good. This number is prime. So it is 1 and 7. And let me tell you this. Knowing all your prime numbers for the test you're going to take on Thursday, all the prime numbers that are between 1 and 100 might be helpful. And some of you are looking at your prime number chart you put in your journal, and you don't know whether the crossed off numbers are prime or the circled numbers are prime. You probably ought to put a little key there so you can know the circled numbers are prime. I'm just saying. Can 10 be prime? No, Ashley, because the only even number that is prime is what, class? 2. 2 is the only even prime number. Hey, y'all out there, write that down. Write down 2 is the only even prime number. All right, so my factors of 2 are going to be what? Regan. Of 10, sorry. My factors of 10.
1 and 10. 2 and 5.
That's it. Blaine, what factors do these two numbers have in common? Do they have a 1 in common?
Yes.
Yes.
They have.
Do they have a 7 in common?
No.
Okay. Since that's all there is there, this makes my greatest common factor equals 1. So if I divide 7 divided by 1 is what, Blaine?
7.
And 10 divided by 1 is what, Blaine? 10. So if my greatest common factor is 1, my fraction is already, and I mean already, in simplest form. So let's try a second one And I'm going to turn y'all loose on your owns. Let's see. All right, we will do 1/4 plus 1/12. 1/4 plus 1/12. And those of you that know your multiples of 4 and 12 pretty easily, this wasn't, are you crazy? I meant that pretty easily. Then you could probably figure out what pieces here. When we do 1/4, which is yellow, plus 1/12, which is pink. Now your colors may be different on your fraction pieces. And so now, is this going to be, Antonio, is this going to be a proper fraction that is less than 1 or an improper fraction that is greater than 1? Good, it's a proper fraction because it is less than 1. This bottom strip would have to go out past 1 to make it an improper fraction. All right, so now we need to find pieces with the same denominator that are going to stretch exactly the same amount here. So let's take my thirds. Oh, thirds are just a tad bit too short.
What? Yeah.
Look at it. It's right there.
Yeah.
Is it just a tad bit too short?
No.
Looks like it might be.
No.
Exactly right.
It is.
No.
Yes, it is.
It's right. Exactly right.
I think it's. Well, let's try.
I can see it.
Let's try.
Yeah, I can see it.
Let's try if we can do 12ths. And I picked 12ths because I know we can.
Why is it
Ruin it.
Does it matter? Okay. Okay. So we're looking at this. And my 4/12ths match exactly. So if I just pull this down for just a minute, I know 1/4 is going to equal 3/12ths. And I know 1/12 is going to equal 1/12. Now you all know how to add fractions if they have a common denominator.
Yeah.
If the denominators are the same, you should be able to add fractions very easily. So let's go with, I don't know, Hannah. What is 3/12ths plus 1/12, Hannah? 4/12ths. Because we know if they have the same denominator, we only add the numerators. Denominator must stay the same. But now I told you moments ago, you have to see if you can simplify this fraction. And to see if you can simplify a fraction, you're going to have to find the greatest common factor. So, of my numerator and my denominator, sorry, that's least common multiple. Of my numerator and my denominator, I need to find all of the factors. Tucker, is 4 a prime number?
No.
No, because the only even prime number is going to be 2.
Yeah.
I hate for some of you to have to sit in the hall when I film, because that would be annoying. So 4 is not a prime number. So Tucker, tell me the factors of 4.
1, 4, and 2.
Good. 1, 4, and 2 times 2. We really don't need that second 2. So my factors are 1, 4, and 2. Janelle, is 12 a prime number? No, because the 12 is even, and the only even prime number is 2. So Janelle, tell me my factors for 12.
1, 12, 3, and
2 and
6.
6.
Oh, 9.
2 and 6. So Tristan, please tell me what they have in common.
They have 1 in common.
Good, they have a 1 in common.
They have 2 in common.
2 in common.
And a 4 in common.
And a 4 in common. So they have 1, 2, and 4 in common. So if they have 1, 2, and 4 in common, Riley, what is the greatest common factor? 4. So my greatest common factor equals 4. Once I know my greatest common factor,
Teachers, pardon the interruption. At this time, if you have any students that have not had their picture retaken, please send them to the small gym. Any staff that needs their pictures retaken, please go to the small gym at this time.
awesome. So I know my greatest common factor is 4. So I'm going to have to divide the numerator and the denominator by 4. The numerator and the denominator by 4. So Caleb, what is 4 divided by 4?
1.
1. And Caleb, what is 12 divided by 4?
3.
3. So my simplest form is 1/3. These should match exactly. Now sometimes the foam gets stretched out a little bit or condensed a little bit just because of the humidity. But my final answer, if we were playing Who Wants to Be a Millionaire, I'd say Vincent. You said 1/3. Is that your final answer?
Yes.
Yes. Let's go to the board. A, 1/3. You win $1 from Gage. All right. So that is how we use the fraction strips to add fractions with unlike denominators. In your book, you're going to do page 199, 1 through 10. Now, if you were smart and watched the video I filmed yesterday during tutorials, you probably have 3 of those answers already done. I'm just saying. So, boom, shakalaka. Peace out. God bless. Love y'all. Do something kind.
Gage, where's my